All right, guys, welcome back. Today we're going to be diving into chapter 7, and this is all going to be about vulnerability discovery. Now, in our previous sections, we've talked about reconnaissance and finding our targets. Now we're going to move on to the phase where we identify the actual weaknesses of those targets so we can exploit them. So, here's our roadmap for the chapter. First, we're going to cover concepts of scanning, specifically the differences between authenticated and unauthenticated scans, agent and agentless approaches. Then we'll talk a little bit about testing tools, and we'll talk about 3 different categories. We're going to talk about DAST, tools like Burp Suite and Zap. We'll talk about network scanners like Nessus and OpenVAS, and finally we'll look at SAS and fuzzing, which involves a little bit more of static analysis, which are more advanced stress testing techniques that we use on software to see if we can find any weaknesses or vulnerabilities. Now let's start with some of the high-level concepts. If reconnaissance was about finding the doors, vulnerability scanning is all about checking the locks. Now we want to see if those locks are broken. So we're going to define this in 3 major distinctions today. First one's going to be authenticated versus unauthenticated. Do we have a password, or are we scanning as an outsider, like a traditional hacker? Are we network versus web? Are we scanning server infrastructure, or just application logic? And then we'll talk about agent versus agentless. How are we getting the data? Remotely or locally? Now, the blueprint analogy here, we need to understand the difference between enumeration and scanning. And enumeration is simply making a list of parts. It tells you this is an F-150. You know what it is, but you don't know if it's safe. Scanning is taking the list and checking it against a recall database. Now the scanner is going to look at the model and say, hey, this specific model has a faulty airbag. So in this phase, we're no longer just asking, what is this? We're asking, is this specific version vulnerable? Does it have any weaknesses? So that first type of scan was an unauthenticated scan. Think of it like an outsider or a black box approach. You're scanning the target from the outside with no credentials. This is useful for finding things like the low-hanging fruit. Weak passwords, maybe unpatched software, maybe TLS or SSL issues. However, because the scanner cannot log in, it can miss a lot. Like internal patch levels or even registry keys. It can only do what it can see from the outside. So the risk here is going to be high false positives. The scanner is essentially guessing what is running based on the banners, and a lot of times it can be wrong. On the flip side, we have authenticated scans. This is the insider, or the white box approach. Here we're going to give our scanner full credentials like SSH keys for Linux, or maybe SMB credentials for Windows. And this is going to allow the scanner to log in and look at the file system directly. If it finds missing OS patches, insecure configurations, and installed software that's not visible from the outside, then we can finally see everything. The accuracy is high. For a comprehensive audit, we always are going to try to prefer an authenticated scan. Now, it's going to be critical that we pick the right tool for the right job. Typically, we divide scanners into 2 different buckets. The first one is infrastructure scans, otherwise known as network scans. They're going to look for things like Windows updates, open ports like 445, or weak SSH keys. The big players here are going to be our Nessus and our OpenVAS scanners. On the other hand, we may be using web app scanning. We're going to want to look at the application logic. They don't care about the server operating system. They care if the login for the SQL injection or if the search bar is going to allow things like cross-site scripting. Now we use different tools for this one as well. We use tools like Burp Suite and Zap. And our final concept for today on how a scanner touches the target is going to be agent versus agent lists. Now, agent based is the resident. You can install a small piece of software on every host. We're talking about every laptop, every server, maybe even every mobile device. And we're going to report that back to a centralized server. Now, the pro here is it scans every laptop when they're offline or even off the corporate network. Now, the con though, maintenance is a headache to manage, because especially if we have thousands of endpoints. Now, we can also look at agent lists. Agent lists then reports back to, or is started by the scanner itself. The scanner is touching every endpoint on your network, causing heavy network traffic. Okay. It makes for easy deployment because it has no installation, but it can cause bottlenecks within the network. Now let's get into tools themselves. These are the engines of vulnerability management. We're going to look at 3 of them: Nessus, OpenVAS, and Qualys. And as we go through this, each one is going to show some strengths and weaknesses. So here's how the industry standard tools stack up. Nessus itself is the gold standard. It's commercial, which means it costs money, but it has a massive plugin library and is very, very fast. OpenVAS is the open source alternative. It's free, powerful, found on many different Linux operating systems like Kali and Parrot, but it has a steeper learning curve. Lastly, we have Qualys, which is a cloud-based scanning program. It's on a SaaS program, so it's heavy on agents and designed for enterprise scale. Now, if you're running Nessus, the workflow is pretty straightforward. First, you're going to get a new scan. You can select either advanced scan or even a basic network scan. You can enter your targets. This is IPs or CIDR ranges. You may want to put some credentials here. So if you want to have an authenticated scan, you're going to put in your SSH or Windows credentials. And then we just launch it. And we wait for the results. It's pretty quick and easy. OpenVAS, which is now referred to as Greenborn Vulnerability Management, GVM. You could see this on the exam as the fully open source option. So if you see this on the Pentest Plus, that's what they're asking for. It's usually pre-installed or easily available on Kali Linux. However, unlike Nessus, it requires more manual setup regarding targets, tasks, and scheduling. Now, regardless of the tool that you use, you must configure the scan policy. This is going to be the brain of your scan. Don't just click scan all. That's very inefficient. You're going to need to tune it. So for discovery, which ports are we checking? Should we check all 65,535 ports or just the top 100? For plugins, what type of server is it? Is it Windows? Is it Linux? If we don't have any Linux in our environment, why do we even look for Linux at all? Let's turn it off to save some time. And then also on performance, we may want to slow it down. If we scan too fast, you can crash a network or even the target service. We don't want to DDoS ourselves. Now, there is going to be safe checks. This is one of the settings you must memorize for the exam and for real life. Safe checks. You typically want to leave it enabled. Safe checks ensures a scanner does not run plugins that are known to crash services or cause denial of service attacks. If you're scanning a production network during business hours, disabling safe checks can take down the company, and we don't want to do that. Now let's shift gears a little bit. We were talking about scanning. Now let's talk about a little bit about testing. So the first one I want to talk about is DAST. It stands for Dynamic Application Security Testing. This is strictly black box testing. We are testing the running application without seeing the source code. DAST tools are great for running runtime issues like SQL injection, cross-site scripting, and even broken access control. However, the tool needs to be smart enough to handle login sessions and navigate complex logic, or it won't scan deep enough. Now, the primary tool, if we're dealing with web assessments, is going to be called a proxy. Okay. Now, a proxy itself, think of this as being a man in the middle or an on-path attack yourself. A proxy sits between your browser and the server, and it allows you to pause every request, inspect the data, modify it, maybe even changing the price from $100 to $1, and then send it to the server and see what happens. Now, the industry standard for our standard proxy is going to be Burp Suite. It has two main components that you need to know. It has the proxy. This is what intercepts the traffic itself. It has the repeater. This is what lets us manually replay attacks, tweaking one character at a time if we want. And then lastly, it's got a scanner. Now, the scanner is a pro-only feature, and you do have to pay for it. But it also includes the automated vulnerability scanner that also runs in the background. So if you do pay for it, you can have the scanner as well. Now, if you don't have the budget for Burp Suite, there's always going to be another tool. Your best friend's probably going to be OWASP ZAT. Z Attack Proxy is what it stands for. It is a fully open source, free alternative. It includes automated scanning, spidering, and fuzzing right outside the box. It's excellent for automating CI/CD pipelines because it is also scriptable and free. Did I mention free? So we can make automated scripts to run through OWASP ZAP as well. Sometimes those general tools aren't going to be enough, and so we have specialized scanners for specific technologies. First one's going to be Nikto. Nikto is a web server scanner. It finds dangerous files, outdated server versions, but it does not test application logic like the login forms. So that's something that it's one of the weaknesses. Another tool would be the WP scan. It's a strictly WordPress scanner. It enumerates different things like vulnerable plugins, themes, and users. So if you see a WordPress site on an engagement, this is the first tool that you like to run. Now, once we get past the DAST code, we may want to go into SAST. And so we may want to look at the code itself. Static analysis, otherwise known as SAST, analyzes source code without running it. It allows us to shift left with our security. So we're going to find bugs early in development before the app is even built. It provides 100% code coverage, but the problem here is it can generate a lot of false positives because sometimes it doesn't understand context. And it can't find runtime logic, well, because we're not running it. These things normally are configured during when we're setting up the software. And so we can have permission issues that we'll never see. So how does SAST actually work? Well, we're going to use a few different techniques. First thing we're going to do is we're going to use AST, the Abstract Syntax Tree. It maps the code structure. Then we take it to the data flow, where we're going to track the data as it moves through variables. And then finally, we're going to do an taint analysis, which traces all untrusted user input, the source, to see if it can reach maybe a dangerous function, like a SQL query. Did we clean it first? Did we validate the user input? If not, well, that's going to be a big no-no, and that's what's going to find in SAST. Ooh, this slide is really hard to read. For the exam, you're going to need to know some of the following. SAST happens during the coding or the build phase. It looks at the blueprint. While DAST is a running test, and it runs during the staging phase. It looks at the finished house, the finished products, and runs the software to see if it finds any weaknesses. All right, finally, we're going to have some advanced techniques in this chapter that bridge the gap between standard scanning, and it's going to be interactive testing and fuzzing. So the first one is going to be interactive testing. This is often referred to as interactive DAST. Now, the reason for that is we're going to bring the human and the tool together. This is where we're going to bring a tool like Burp Sweep in to manually dive into an application. Because a human is clicking through the complex workflow, you can test business logic flaws that automated scanners are probably going to miss. Like maybe negative prices or privilege escalation, or even skipping steps in the shopping cart process. These are different things that we could be looking for. Lastly, we're going to be talking about fuzzing. I like fuzzing as automated chaos. Fuzzing involves sending a large amount of random, invalid, or just unexpected data as input to the system. And we want to make it crash. The goal here is to try to create buffer overflows, a crash itself, or even unhandled error messages. We fuzz everything from web forms to file parsers like FTP, PDF readers. You can fuzz also an FTP server. It's different network protocols. All right, we talked about a lot today, so you may want to slow down and go back through this chapter a little bit, kind of really get those terms strong, because when you do take the Pentest Plus, they're going to test you basically on this terminology. Do you know where and when things are used? What tool would be the best tool? And why is that? Okay. So we talked about authenticated scans because they're more accurate than unauthenticated. We talked a little bit about tools like Nessus and OpenVAS to find infrastructure flaws. We talked a little bit about Burp Suite and Zap to find application logic flaws, otherwise known as web flaws. And then we talked about DAST and SAST to find bugs in source codes and running software, respectively. So now this is going to conclude a vulnerability scanning chapter. We've identified a ton of flaws. So in chapter 8, we're going to discuss vulnerability analysis and how to prioritize and report what we found. If you have any questions, let me know. Otherwise, I will see you for chapter 8.